Today's topic is square root. Square root of perfect square numbers. We will be using ladder method to solve square root of perfect square numbers. Let's get started. Let's first understand what is meant by squaring a number. Squaring of a number is a simple process. It can be defined as multiplying a number by itself. Thus, for example, if we multiply 4 by 4, we said to have squared the number 4. The symbol of square is represented like this by putting a small 2 on the right upper corner of the number where x is any number to be squared. Let us now take a look on few more examples. Suppose we need to find square of 8. Do you know how do we represent it? We will represent it by putting a small 2 on the right upper corner of the number 8 in the same manner as shown to you. 8 square can be solved by multiplying 8 by itself. That is, 8 multiplied by 8 gives you 64. This is how we have found that square of 8 is 64. Similarly, square of 5 is 5 multiplied by itself and gives answer 25. This method of squaring a number stands true for any number in mathematics. To understand square root, let's watch a video first.
So we are going to start off our discussion by looking at a rectangle, and this rectangle has a width of 4 units and a length of 8 units. Now we're going to envision this in terms of area. So that width of 4, think of that as 4 equal sized units. That will split it up along the width. And then for the length, we have 8 equal sized units, which we will split it up along the length. And now we have these squares that make up the inside, the area of that figure. Length times width, in this case 4 times 8, which we know is 32. So the area of this rectangle is 32 square units. So now let's look at what would happen if we cut this rectangle in half. So now instead of it being a 4 by 8 rectangle, it's a 4 by 4, which makes it a square since all of the sides have the same length. The area of this square, 4 times 4, we know is equal to 16 square units. And this relationship allows us to say that 16 is a perfect square, and also that the square root of 16 is 4, since 4 squared equals 16. And we can think of this relationship every time we think about perfect squares. Now, for example, if we took this 4 by 4 square and cut each unit in half to make it 8 by 8, now if we counted up all those squares to find the area, or just multiplied 8 by 8, 8 squared, we would get a result of 64 square units. So 64 is also a perfect square, and the square root of 64 is 8, because 8 squared will equal 64. So now we can say that a perfect square is a number that can be made by multiplying a whole number by itself, by squaring any whole number.
Cool.
So now we can revisit the two perfect squares from earlier, and that was the 4 by 4 square and the 8 by 8 square. Now 4 times 4, if we think of this in terms of area, is 16, which is equal to 4 squared. And 8 times 8 is equal to 64, which we know is equal to 8 squared. Notice again that 4 and 8 are both whole numbers. Now if we take the square root of 16, our result is 4. And if we take the square root of 64, our result is 8. So the most important thing to take away from this lesson is that relationship between a perfect square and its square root. And now we can explore that relationship a little bit more. Let's take a look at an example of a perfect square of 25 and a non-perfect square, 30. Now 25 is a perfect square because 25 is equal to 5 squared. and the square root of 25 is equal to 5, which is a whole number, so by definition, everything works out. A non-perfect square, 30, if I take the square root of 30, I get approximately 5.48, which of course is not a whole number. So there is no whole number that we can square to get to 30 the way that we can square 5 to get to 25. Now 25 and 30 are pretty close to each other in value. And if we think about these two numbers in terms of area, again, we know that 25 is a perfect square that has dimensions 5 by 5. And if we think about that area in comparison to that 30, if we slide it over, we see that it kind of fits, but there is some room left over, that orange space, which doesn't quite hold one full square. It only holds about half of a square, which is where that 0.48, that decimal, comes from. And again, this is because there is no whole number that we can square to get to 30. We'd have to have a decimal value in order to approximate a square root for a number like 30. So now we're going to go ahead and visually explore some of the most common perfect squares and their relationship to their square root. So 1 squared is 1 times 1, which just equals 1. 2 squared is 2 times 2, which equals 4. 3 squared is 3 times 3, which equals 9. 4 squared, again, 4 times 4, which equals 16. Again, these are all perfect squares. 5 squared is 25. 6 squared, 6 times 6 equals 36. 7 squared is 7 times 7, which equals 49. 8 squared is 8 times 8, which equals 64. We actually looked at that one earlier. And 9 squared, 9 times 9, is equal to 81. And the square root for each one of these perfect squares is the value that you had to square to get it in the first place. So for example, the square root of 4 is equal to 2, the square root of 9 is equal to 3, the square root of 16 is equal to 4, and so on and so forth. And this is why raising a number to the second power, or the power of 2, is referred to as squaring the number. So those are the basic concepts involved with perfect squares and square roots.
After understanding about square, perfect square number, and square root of perfect square number, let's learn a method which is called ladder method to understand how we would find the square root of perfect square numbers. Let's take up an example to solve square root of 7744. Let us start with drawing the steps of ladder, writing the given number at the top. On the left side of the steps of ladder, we will write smallest prime number that can exactly divide the number 7744. We know that 2, which is a prime number, can exactly divide the number 7744. Let us write 2 on the left and start dividing. When we divide 7744 by 2, we will get quotient 3872. We will write the quotient at the bottom step of the ladder. This quotient can be exactly divided by 2 and gives quotient 1936. We will write this quotient at the next bottom step of the ladder. 1936 can exactly be divided by 2 again and gives quotient 968. We will write 968 exactly below 1936 on the ladder. Again, 968 can be divided by 2 to give quotient 484. Write this quotient on the next bottom step of the ladder. 484 again goes into 2 to give 242. We will be writing 242 on the bottom step of the ladder below 484. Then we will divide 242 with 2 again because it can exactly divide it by 2 to give 121. 121 is the bottom next step of the ladder. As you can see that 121 cannot be exactly divided by 2. Therefore, we need to find a prime number that can exactly divide 121. 11 is the next prime number that can divide 121 perfectly. We will be writing 11 on the left and we get 11 as quotient. The quotient 11 is next bottom step of the ladder. 11 can go into 11 and it is a prime number in itself. 11 divided by 11 gives 1, which is the last step of our ladder. While finding square root, we will stop when we reach at 1. In the next step, we will be listing down all the numbers we got on the left side of the ladder. These numbers are 6 times 2 and 2 times 11. We will make pairs of these numbers. In this case, we will get 4 pairs. 2 multiplied by 2 is the first pair. 2 multiplied by 2 is the second pair. Again, 2 multiplied by 2 is the third pair. And 11 multiplied by 11 is the fourth pair. We will take one prime number from each pair. 2 from the first pair, 2 from the second pair, 2 from the third pair, and 11 from the fourth pair. Then multiply these numbers, that is 2 times 2 times 2 times 11, and we will get 88. Therefore, 88 is the square root of 7744. Let's try one more example and find the square root of 9801 using ladder method. Let us start with drawing steps of ladder and writing the number 9801 at the top. We need to find the smallest prime number which exactly divides 9801, as sum of all the digits of the number 9801 makes a total 18 and 18 is divisible by 3. Therefore, 9801 is exactly divisible by 3. When 9801 is divided by 3, it gives 3267. We will write 3 on the left of the number 9801 on the ladder and 3267 exactly below the bottom step of the ladder. Again, 3267 is divisible by 3 and it gives 1089. Write 1089 on the next bottom step of the ladder. This number is again divisible by 3 and gives 363. Write 363 on the next bottom step and write 3 on the left of the ladder. 363 is divisible by 3 and gives 121. Write 3 to the left of 363 on the ladder and write 121 on the next bottom step. 121 is divisible by 11 and it gives 11. 11 in itself is a prime number and it gives 1. Here our ladder is complete because we have reached at 1. Let's do the final step and write the numbers we got on the left of the ladder to make pairs. We have 3 times 3 times 3 times 3 times 11 times 11. Taking one number from each pair and we get 3 times 3 times 11, which is 99. Therefore, the square root of 9801 is 99. In the same way, we can solve the square root of all the numbers which are perfect square numbers. But you must be well versed with the prime numbers. I hope you have enjoyed and understood the ladder method of finding square root of perfect square numbers. Let's practice this method by solving square root of following questions, and these questions are perfect square numbers. Your first question is, find the square root of 1936. Your second question is, 15,625 and you have to find the square root of this number. The answers to these questions will be given to you once you have completed the square root of these numbers.